Let's pay attention so that we understand whatever we are talking about. So the question is saying that three displacements of a vector, three displacements of the vector A is equal to 3 meters, 20 degrees above the x-axis, B is equal to 10, 100 degrees with respect to the positive y-axis, and C is equal to 5 meters, 20 degrees, 220 degrees with respect to the positive x-axis, lie in the same plane. Find the resultant displacement of the vector. So the first thing that we have to do is to graph whatever has been given. So for us to understand the question on the board, we have to graph, then we see how we can find the displacement. Okay, so now let's write our xy coordinates, okay, or our y and x axis, x or y plane. So we have something like this. So this is our y, this is our x. So let's take this side to be negative x, then this side to be positive x. Let's take that side to be positive y. Let's take that side to be negative x. So we have 3 points. That is point A, point C, and point B. So the first statement is saying that A is equal to 3 meters and it is 20 degrees above the x-axis. So this is your x-axis. And if you are rising from the x-axis going upward, okay, the angle begins to widen up, going like that until it forms a 360. But our question is saying that A is 3 meters and it is 20 degrees above the x-axis. Okay, so you write it like that. You are arising from the x-axis going upward like that. So you have your A as that one there. That is your A. Okay, and it is 3 meters above the x-axis. So let's look at point B. Now point B is saying that it is 10 meters with 100 degrees with respect to the positive y-axis. Take note of that. It is with respect to the positive y-axis. So when they say to the positive y-axis and it is 100 degrees with respect to the positive y-axis, your y-axis is this line, okay? Your y-axis is that line. So if you begin to rise from this line, okay, so we know that if I reach this point, it's 90 degrees. I make a 90 degrees here. So if I add another, so from 90, for me to make 100, it means that I'm coming somewhere here, isn't it? So that is where you find your 100 degrees, okay, to the positive y-axis. When they say with respect, they are giving you the starting point. So for example, if they say with respect to the negative y-axis, we are going to start from this down part, that is negative y-axis, okay? Then to the positive y-axis, positive, you are going in that direction. Negative, you are going in that direction. Just the same with when they say to the positive y-axis, positive x-axis, I'm arising from A, from X. Then negative x-axis, I'm going down like that. So same with your B. So B is rising from the positive y-axis. Okay, it's coming down to that point. So I have 100 degrees and it is 10 meters to the positive y-axis. Okay, 100 meters. Are we clear how we found this answer? Any question? Okay, I believe that there is no question. And that it is 10 meters, not 100 meters. That is your 10 there. That is how we plot our point. Let's go to another point, C. C, they said it is 5 meters and it is 220 degrees with respect to the positive x-axis. Okay, this one it's saying with respect to the positive x-axis. So when you begin to rise, you start from this point, not the y line, because this point is saying that it is rising with respect to the positive x-axis. So from starting from this point, going that direction, and I want my angle to be 220 degrees. So I know that from this point to that point, it's already a 180 degrees. Okay, so 180 degrees. So for me, I'm remaining with about 30 degrees, isn't it? So I'll just add about an angle there. So somewhere here, okay, you are just approximating, and it is 5. Okay, 5 meters. So that is point C. So point A, point B, point C. We have our diagram. Okay. So when you have your diagram, you have to draw and see what your resultant vector will come out. So what do I mean when I say you have to draw? Okay. Hello guys, let's mute our mics for I'll ask questions. If you those there are those that have questions, I'll give you time to ask. For now, listen so attentively. So now we come back to the question. How are we going to write our vector? Okay, how are we going to write our vector? So what we are going to do, so we are going to draw a table of values like this. Okay, we're going to draw a table of values. So this table of values will help us to find the resultant vector of our points A, B, and C. So let this be the vector that you have been given. The first column represents the vector. The second part, you write the x component, okay? The x component. This is the x component of my vector. And that other end, you get the y component, okay? The y component of my vector. So I have three vectors. That is vector A, vector B, and vector C. Okay, then here I'll write my resultant vectors. Okay, resultant vector. So we draw a table of values like that. Okay, so from there, let's find the x and the y component of our vector. So our diagram for our vector looks like that. Okay, remember that when we want to find the x component and the y component of our vector, we get, so the vector is that point. So this is the x component, the y component of that vector, then the x component is that. Okay, those who attended the lecture yesterday, we said that if we get this to be a triangle, okay, we get that to be our triangle like that. Okay, let that be our triangle and let that angle be your theta. Okay, the angle has already been given to be 20 degrees. We said it's 20 degrees, and the magnitude of this angle has been given to be 3. So, and that is your point A. So we are interested to find the x component and the y component of that point. Okay, so now let's take this to be our SOHCAHTOA, okay, trigonometry, we say SOHCAHTOA, okay, SOHCAHTOA, in case there are those that missed the lecture for yesterday, we said SOHCAHTOA. The S represent the sine, the cosine. If we want to find the x component, okay, so we know that this is the adjacent. If we go back to trigonometry, this one becomes the adjacent, that becomes the opposite, and that becomes the hypotenuse, meaning that when I'm finding the x component, I say, so we say the magnitude or r, the magnitude that has been given for component A, and times the cosine angle. Okay, that is how we find the x component, this x component. Then the y component of that part is given by, you get your r, your magnitude, which is r, then the sine angle of that diagram. Okay, so this one with respect to the diagram that we have been given. So what do you mean? So let's say if I want to find my x component, I write the magnitude of that diagram, which is 3, times the cos angle. The cos angle I'm given 20. So for the y component, I'll get 3 sine 20. Okay, sine 20. That is what you write in the diagram. Okay, that is what you write in this part. Let's say we have A, B, and C. Okay, so we said the x component of that part is given by r, or 3 cosine theta, which is 20. And when you punch on your calculator, what do you get? You get about 2.81. Okay, then the y component is 3 sine 20 degrees. Then when you punch on your calculator, you get something like 1.03. Okay, I hope we are verifying our numbers. So let me ask, is there anyone who has a question from whatever we've discussed? Is there a question before I proceed? No question? Okay, so
I
let's go
didn't
back.
understand why.
Hello?
I didn't understand how those y coordinate ya masaini makosi.
All right, no problem. Let me go back again. So you've understood where how we drew this diagram, isn't it?
Yes.
Okay. So now, to take you back a little backwards, let's say we have our x or y plane like that. Then we are given this line to be a. Okay. So I'll get this portion here, this portion. That is the portion we have written at that point. I've just removed this part and I drew it here for easy understanding. Okay, this angle that is here we said is 20 degrees. It is the same angle that I've written here as 20. Then the 3 is that part which is 3. So our duty or our interest is this line that is going upward and that line that is going like that, because this line and that line, it is the one that is giving the magnitude 3. Okay, so that line and that line, they are the one that are giving us the magnitude of 3. So we want to find the component x, okay, or the horizontal component of our vector and the vertical component of our vector. Okay, so now the sine and the cosine comes from our trigonometry that we learned. Okay, we said the SOHCAHTOA, sine is equal to opposite over the hypotenuse. Sine theta is equal to opposite over the hypotenuse. Cosine theta is equal to adjacent over the hypotenuse. Okay, so now our sine theta is already a 20, or let me say the opposite is the y component and the adjacent is the x component. So without wasting much of the time, let's say sine theta is equal to opposite, which is the y component of my vector, and the hypotenuse. Okay, then the hypotenuse becomes your r, okay, your resultant vector. Then same with the cosine part, we say cos theta is equal to the adjacent, which is the x component of my vector. So it becomes x over the magnitude, which is r. Okay, so now we are going to make y the subject of the formula, assuming that we are finding the magnitude of the y component. So if we cross multiply, we're going to get something like r sine 30 or sine theta, sorry. Even here, we're going to get something like that, which is x is equal to r cosine theta. So we are just going to replace where there's theta, we go back. The theta is the angle from the positive. We always get the angle from the positive x-axis, okay? From the positive x-axis, which is 20. And the r part is this part, which is 3 meters. Okay, any question from there? I hope you are clear.
Question.
Hello? Yeah, no
Yes,
problem. You can
sir.
ask.
Is it always that when you are finding your x components, you're supposed to use cosine rule?
So, okay, thank you. That's a good question. Okay. So now let's assume that we draw our triangle like that. Okay. We say the resultant vector is in that position, for example, C. Okay. So let's say we want to find the y component and the x component. Okay. So theta in this case is here. Okay. So it depends with where your theta is. But if your theta, for example, you've been given that it's there, so the x component changes. But in physics, I don't think they can give you your theta to be there. So we're going to stick with yes. For now, it's always going to be like that. Okay, but unless if the theta sometimes comes there, that's when we can change the components. But if you don't want to confuse yourself, continue using SOHCAHTOA because you can't get confused when you use SOHCAHTOA. Have I made myself clear?
Yes.
All right.
Okay,
I
have a
had someone had a
question.
question. Yeah, you
Yes.
can ask.
Yes, I was asking on the theta and the phi
Okay.
because our lecture today introduced us to theta and the phi. So I was
Okay.
asking,
Hello. I
this
didn't get the
triangle
question,
that
please.
is starting from y, this
Hello.
triangle that is starting from y,
Oh, hey.
is it a theta or a phi?
Okay. Pi is something else. Okay. So the angle always is represented by the Greek symbol theta. Okay. Pi is a number. Don't confuse pi with theta. Are we together?
I'm talking about the
Hello?
phi, not the pi. I
The
was
phi
asking about the phi, the pi.
or phi? Okay. Okay, we are going to stick with theta. Okay. Are we together?
Okay.
Yeah, let's use
Yes.
theta for angle. Yeah, you can use phi, but let's stick with the theta. Are we together? I hope everyone is clear how we got the x and the y component for our first vector, isn't it?
Yes.
Okay, so now let's go back to, in fact, on B, okay, what are we going to do? We said B is 100 degrees from the positive x-axis. Okay, so now we don't want the entire angle here. We are now at B. We want to find the x component and the y component for B. So remember, our angle has been given as 100. So are we going to get theta as 100D? The answer is no. Okay, the answer is no. We just want an angle that is starting from there. Okay, at this point. So what we are going to do, we are going to say, since my angle 100 is from this point to that point, okay, but I know that in mathematics, if I draw a Cartesian plane like that, this is always a 90 degrees, okay? So this is a 90. So a 90, so we're going to say 100 minus 90. What are you going to get? You're going to get a 10 degrees there, okay, as your angle theta. So we are going to proceed finding the y component and the x component. Let me again take this part and put it here so that people understand clearly. So it's like this. So let's say this is my vector B, and it is 10 meters, okay? And the angle that has been given, we said, is 10 degrees. We are not going to use the 100 because we are going to start from this point, okay? Because the x component that we want to find is that part, and the y component is that. So now, let's say we want to find the x component and the y component. So we said this will be our adjacent, and that is our opposite. So for this case, the same thing will happen. The x component will be given by r cos theta, okay? Then the y component will be given by r sin theta. Are we together? Like that. So for the x component, we're going to say the x component is equal to, my r is 10 meters, then cosine theta, and cos theta in this case is 10 degrees, okay? Are we together?
Yes.
Then now for the other part, we're going to say the y component is equal to 10 sine theta. Okay, so which is 10 degrees. So we're going to put them back into our graph or diagram that we have written here for easy computation. Let's say 10 cosine theta, which is 10. Okay. And when you punch on your calculators, guys, what do you get? Let's make our tutorial interactive, okay? Feel free to
You
participate. Okay, what do you get when you punch on your calculator? And make sure your calculator is in degrees, not in radians, okay? What is 10 cos 10? It's negative 8, isn't it? Negative 8.39. Okay, just confirm if you're getting the same answer. Even here, we're going to say 10 sine 10. Okay, 10 sine 10 is equal to, what is the answer? Guys, let's mute our mic. Zoom user, let's just, hello guys, we are making a lot of noise. Yeah, thank you very much for that. So now, what is 10 sine 10? What is 10 sine 10? So my calculator is giving me a negative
1
5.
point.
Okay, negative 5.44. So you can ask yourself, I'm getting negative answers in both the x and the y component. They are positive answers. So is it true? Let's go back to what we learned in mathematics. Okay, we said here, if your answer, okay, if the angle is in the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant, okay, if you're given something like that, okay, so you know in the first quadrant both positive x and y are positive. Okay, take note, both x and y are positive. In the second quadrant, x is negative, y is positive. Okay, in the third quadrant, as you can see, y is negative and x is equal to negative. Then the last quadrant, x is positive, y is negative. So yes, it is in the third quadrant, so x and y should be negative. So yes, the values are correct. Let's go back to our C now. What is my vector component for C? I hope we are following. Any question from there? Is there any question? Okay.
I have a
Silent
question,
means
sir.
this. Yeah, you can ask, sir.
Concerning vector B. Okay.
Yes.
I didn't get concept clearly
Hello?
there. I had
Okay,
some breaking down of the network.
okay. Thank you very much for that question. So, since we've already explained it, let me just explain it. Okay. So I'll post this video on YouTube for you to follow it through again. Okay. I'm recording this video. So if you don't get it, please watch it again on YouTube. Okay. I'll post this video. So let's say we said I'll draw it here since it's not clear. Okay. So let's draw it like that. We have a point there. And we said this point is arising from the positive y-axis and it is 100 meters. Okay. It's 100 degrees, not meters. Okay, it's 100 degrees from the positive y-axis. That is what my question is saying, isn't it? That is point B.
Yes.
And this point B is 10 meters. Okay, arising from the positive y-axis. Okay, so let's find the x component and the y component of that. Okay, so what we're going to do, we are going to get this triangle part only. Okay, because we want this component and we also want this component, because these two components are the components that are giving the magnitude 10. Okay, so now we know the rules of mathematics. This is a 90 degrees, this is a 90 degrees. So already, so from this 100, okay, if I remove a 90 degrees, I remain with a 10. So meaning that inside my triangle, the only angle that I'm interested in is a 10. Are we together? The angle
Definitely.
that is there is a 10. So I have 90 and a 10. So this 100 is just trying to make sure that you understand the concept of how we find the components of our given vector. So the 100 has been given because they know that you as a student knows that this is a 90, you are going to subtract and remain with a 10, so that you use that 10 and you use the laws of Kapatova to find the x component and the y component. Are we together? You are clear, sir?
Yes.
All right. So someone has the mic is on. Please let us mute our mics so that we finish the question. I have some nice questions from your tutorial sheet. Okay. I have nice questions from your tutorial sheet. We have a lot to do. So let's go back and let's finish this question. So we are remaining with C. We are remaining with C, the same concept that I've used on the other part, but C is also saying that we are rising 220 degrees from the positive x-axis. So C, I'll draw it here so that people understand it clearly. So I have C there, which is about 5 meters. Okay, not about, but it has been given in the question. It is 5 there. And then they said from the positive x-axis, this C is 210. Okay, from the positive x-axis, this C is 210. The same concept that we applied in B is the same concept we are going to use here. We are going to say that let's just find the angle that is here, because this same angle is the angle that is going to help me to find this component and the y component of my vector. Are we together? So now
Yes.
we already know from the rules of mathematics, this part, okay, a straight line adds up to 180 degrees. So this part is already a 180. So we just want this pi theta, that is the angle we are looking. So we're just going to say 220 degrees, okay, minus 180. We just apply simple rules of mathematics. We know that there, the one, remove it, or sorry, so to be 0, then 8, a 40. Okay, are we together? We have a 40 here as our
Yes.
theta. So the same principle we did earlier, we're going to apply them. So we said our R is 5. Okay. Then for the x component, we use cos theta, and our theta we said it's 40. Okay. So if I punch on my calculator and say 5 cos 40, I'm sure you are all getting a negative 3. Okay. Negative 3.33. Negative 3.33. Even for the y component, we're going to do the same. 5 sine 40. And 5 sine 40, what are we going to get? The same method, we're going to say 5 sine 40 on our calculator, and make sure that our calculators are all in degrees. Okay. What is 5 sine 40? Hello? What is 5 sine 40?
3.7.
Hello? Well, what's the answer?
3.725.
My calculator is saying 3.21. Am I wrong?
Mine. Yeah,
No,
wrong.
it is 3.21.
It's 3.1.
Yeah. So this angle
It's
is in the
sine
third
what?
quadrant. It's sine 40. Even here, sorry guys, my calculator
Oh,
was my calculator was in radians. So let's make sure we punch these again. Okay. Try to punch again
you
and see
said
what we are going to
you
get.
said 5. You said
I said 5 cos 40. What are you going to get?
5 cos 40. It's a 3.7. 3 negative 3.33.
Okay. So it's negative 3 point. Here it's 33, isn't it?
Yes.
If then the other side for cos, you get what? 3.83, like that, isn't it?
No, 5 cos 40. It's negative 3.33.
Yeah, for cos.
Yes.
For
Is
no,
it
no, no.
3.83?
So
Cosine.
5 cos
5 cos
40 is
40.
equal
It's
to
negative
Yeah,
3.33.
why my calculator is giving me 3.83? Check again. Check
Oh,
again.
no,
No,
mine is in radian.
3.8.
Yeah, even mine was in radians. That's the mistake that I made. Even on B
Oh,
part.
yes. So
Your
5
calculator should
cos
even
40.
here.
5
Okay.
cos
Yeah, it
40,
is wrong.
3.83.
Oh yeah, 3.83. So do also on B. My calculator was in radians, okay? Try to do on
Okay.
B. What is 10 cos 10? My calculator was also in radians. So that's the error you need to avoid, guys. Okay.
Yes.
What are you going to do?
9.84.
Okay. So we're going to go back to the concept. It is in the third quadrant. So both positive, they are negative, okay, in the third quadrant. So it's negative 9.84.
Network.
What of the other part? What of the other part? What are you getting for sine?
1.736.
Hello? 1.736.
1.736.
Yeah. So we're going
Yes.
to leave it in three significant figures like that. Thank you. So someone to add the y component and someone to add the component, the x component, so that we just write the final values for the
Sir,
Rx and Ry. Someone
sir. Hello.
Hello?
On the B part, Balkan cos must be in
There is no negative, sir, on the B part. 10
Yeah.
cos 10.
So the negative where it's coming from, let's look at the B, the quadrant where the B is, okay? It is in the third quadrant.
Yes.
If your answer, your B is in the third quadrant, both the values X and Y, they're negative. Take note of that, okay?
Even if you find a positive answer, it should
Yeah,
indicate like a negative sign.
you should indicate
Then
the
when
comma negative
adding,
sign, okay? So
then
if
when
it is in the,
adding, you include,
when
sorry, sir.
adding,
Then when adding, you include the negative.
yes, you include the negatives. That's when you get the resultant vector. You get the point? Yeah.
Yes.
So now try to add and
then on
see
10
what,
cos 10.
here you get what?
Before you add, sir.
Yes.
But B hapo 10 cos 10, sir.
Yeah, 10 cos 10, you got what?
Must be 9.85.
85. Okay, thank you for that. Oh, because we round it off, something like that. Thank you for okay. So
Yes.
someone to add the X and someone to add the Y and give me the values so that we don't waste time. For the X, what do you get?
Negative 10.87.
0.87. Thank you. Then for the Y, what are we going to get for the Y? For the Y,
The C, the y component C, it's 5 sine 40 is equal to what?
negative 3.33.
Negative 3.33.
Yes.
4.04.
Negative what?
4.04.
4.04. Okay. Yeah, you are correct. All of you are correct. Okay. So now when the question is saying find the displacement, they want you to give, so the displacement is a vector. That's the reason you are learning about vectors. You give the direction and the distance and direction. Okay. So you say it is 4 meters rising with an angle from where the positive x-axis. That's what we are going to do. So now for me to find the resultant vector r, so you just find the square root of the x component squared plus the y component squared. Okay, that is the formula to find the resultant vector r. So your resultant vector r is given by, so negative 10.87 squared, then plus negative 4.04 squared. So just someone to punch for me these answers. What are you going to get? What are you getting?
Square root of -1,
Yeah, the square root of negative.
34.47,
So
-134.
no, the square root of 10.87. Yeah, 10.87. 8 is it 87? Yeah, 87. Okay. I hope we are all punching so that we avoid my errors. Okay. Me, I'm getting 11. So just confirm if you're also getting an 11. Me, I'm getting 11 meters. Okay. Let's just confirm.
0.87 in brackets.
So it's the final answer for. So we said they all lie in the same direction, A, B, and C, isn't it? So I want to find the direction, the magnitude of A, B, and C. So in short, we are adding the vector A, B, and C. So if we add the x component of vector A, B, and C, we get a 10, and the y component, we get a -4. So these answers that you get are your resultant component for the resultant vector. So it is the x and the y. So when square rooting, or when you are square rooting, you square root this when you square the x component, okay? And when you square the y component, that's when you get the final answer. Are we together? So now let's find the direction, which is angle theta. So before I proceed, any question?
Yeah, about 11, base 11.596.
Yeah, so it would
So
be
when you
60.
round off,
So when we round it
yes,
off, it would be 11.60,
60.
isn't it? Okay, thank you for that observation. 60 meters. I hope everyone is getting the same answer. So now, when they say find the displacement, we are finding the direction and also angle. The direction is given by the angle theta, and angle theta is given by using tangent. We're going to say tan inverse of ry over rx is our direction. That is the formula to find the direction in any vector problem. Are we together? In any vector
Yes.
problem, this is how you find the direction of a given vector. So now the theta, using the same information that we have been given, so it is tan inverse of -10 over -4. So the negative will just cancel each other. So we're going to say 1087 over 4.04. Even if I write negative, they'll simplify each other, isn't it? So try to punch on your
Yes. So,
calculator and okay, ask.
before you
What do
punch,
you
Okay.
you start with the RY, then you on the what? The answers you have done what Librisket. I
What
have
I
done
didn't hear.
opposite.
Wow,
Jay,
what's the question again?
You have done opposite instead of starting 4.04, you have started with 10.87.
The
Yes.
10.87 is the RX, which is this RX. That is the 10.87. Then the RY.
No, on the
Oh,
direction
okay,
there.
okay,
Formula.
okay, okay, okay. Yeah. Thank you for that observation. Yeah, thank you for following. So instead, we start with the
So,
Y
so sir,
component, not the X. 4.04. Then the is 10.87. Thank you for that observation. So what's the theta? What are you getting as your theta?
0.371.
Are you sure when you say inverse?
The actual answer
Oh.
20.88.
20.389,
389.
20.39,
Joyce,
isn't it?
Joyce,
yes.
Yes.
Yeah,
Joyce.
20.39. That is my angle. Okay. So when you write like that, so you say the displacement of vector is 10 meters uh, 11.6 meters, arising 20 degrees 0.39 from the positive axis is positive, you've seen.
Yes.
So this is the displacement. So that's how we calculate the displacement for the vector. I hope everyone has gotten the concept. We can proceed to another question.
Yeah, I have a question.
Yeah, you can ask, sir.
So you cannot solve without drawing the
Hello?
diagram.
So, those who are not asking question, let's mute our mic so that someone who is asking can get something. Okay, let's just mute our mics. Let's put, yeah, let's mute our mics. Make sure your mic is muted because we can listen to what you are saying. Thank you. So that one who was asking a question, what are you saying, sir?
What can you solve without drawing the diagram?
I think the diagram is convenient because it's showing you a map of where you are coming from and where you're going. So I suggest that you be drawing these diagrams, because sometimes when they are marking, they give you like a 3 here, then for the answer, they give you another mark. So I prefer you draw a diagram, okay? You mean drawing the other diagram, this one?
Yes.
Again, drawing this
This
one,
one.
this one again is going to give you the roadmap. Just look at how we're getting the angles, okay? You have to show on the diagram like this, okay? Is there any
Okay.
other
So,
question?
sir,
We proceed. Oh, Mr. Moses?
sir,
Yes.
I can proceed.
Yeah, okay.
hello, hello.
Yes, sir. You can ask.
I was asking, sir, concerning the resultant displacement vector.
Yes.
Okay, so upon finding the resultant displacement vector, are we supposed to plot it on the graph, provided we have drawn the graph?
Unless if the question is asking you to draw it on the graph. But in this case, they just said find. So no need of drawing. Okay.
Okay.
Yeah, if they say draw, you have to draw. But if they just say find the resultant displacement, they just find the resultant displacement. Are we together?
Yes.
Okay,
One
we are
more
remaining.
question, sorry.
Yeah, you can ask.
So when finding the resultant displacement vector, the magnitude there where we square the resultant x and the resultant y.
Yes.
So we find each value separately, and then that's when we square them.
Yes, we find each value separately, then you square. Okay. Yeah. Yeah, these questions I will be helping you a lot. If you have questions, please don't feel free to ask, okay? The floor is yours. So I assume that everyone has gotten the concept. Okay. So we are on this question now. You can see the question that I've put on the board. Hello, can you see the question?
Yes.
Yes.
Okay. What is the question saying?
I read.
Yeah, you can read for us.
What are A in brackets, the x component, and B, the y component of a vector A in the xy plane if its direction is 250 degrees outer clockwise from the positive direction of the counterclockwise from the positive direction of the x-axis, and its magnitude is 7.3 meters.
Okay, thank you for that reading, madam. So, same concept, guys. The first thing that you have to draw is the x y plane. Okay. The mic is on. Someone is talking. We can hear you. Someone is saying, please, let's mute our mic. So we have the y and the x. Okay, thank you for that. So we have the y and the x. Okay, very important. So before you write anything, the question is saying, what are the x and the y components? Simple question, okay, of a vector A in the xy plane. Okay, this is our xy plane. If its direction is 250 counterclockwise from the positive axis, okay, there's counterclockwise simply means anti-clockwise, okay, anti-clockwise, okay. There's a clockwise, a clock goes like this. If you see your watches, okay, they go like that in a clockwise motion like that. If I say counterclockwise, I mean you move like that. Are we together? So now, from this origin, I have to move a distance of about 250 counterclockwise, moving like that. Okay, so now we know that from this point to that point is 180, and from that point, from this point to that point is 270. So if we make an assumption, my angle lies somewhere in this quadrant. Okay, so it's somewhere in that quadrant. So I can assume that it's from that point to that point. That is my magnitude A. Okay, that is my vector A. Are we together? That is vector A, and that vector A is 7.3 meters. So we want to find the x and the y component. So looking at the question, we have seen that our vector A lies in the third quadrant. Okay, the third quadrant. So if it's in the third quadrant, we know that the y component should be negative and the x component should also be negative, isn't it? So whatever answers I get, they should be like that. Okay, so now let's say the y component is that point. Okay, that point there. And the x component is that point there. Okay, let me use a different ink. Let me use red to draw my components. So let's say this is my y component, and that is my x component, and that is my y component. So x and y. So that is what the question is telling me. For A, find the x component. For y, for B, find the y component. Same principle that we used earlier. So let's get this portion. Okay, let's zoom it a bit here. Okay, let's zoom that point a bit there. So it's looking like that, a triangle that looks like that, isn't it? Then this angle is angle theta, and they said the question is saying that this is my vector A. Okay, and we have been given a 7.3 meters there. So the question is saying find the x component and the y component. So what do we need to find the x and y component? We need the angle theta there. Okay, so how do we calculate the angle? So the angle is somewhere. Hello guys, we are making a lot of noise. Madam Ines Musonda, your mic is on. Yeah, thank you. So from here, starting from that point, we rise to that point, we said it's 270, isn't it? So what we are interested in is the angle that is there. Okay, so but we know starting from that point, going to that point, it's 180 because it's a straight line. Okay, so we know that if I say 270 minus 180, we get the unknown angle theta there. That is the angle we are looking for. So 270 degrees minus 180. What do we get? So simple mathematics, you say 1 there. What is 17 minus 8? It's a 9, isn't it? No, it's not a 9. What is
Sorry, sir.
Yeah, you can ask.
Sir, where has the 270 come from instead of the 250?
It's a 250, in fact, not 270. That's why I got 90. It's a 250, not 270. Yeah,
Yes.
250. Yeah, thank you for that. So, 250 minus 180. What do we get? So a 0, we simplify there, it becomes a 1. What is 15 minus 8?
70. 7.
Excuse me.
Yeah, you can ask Emmanuel.
So I didn't follow you, sir. I had network breakdown.
You had network breakdown. Okay. So just like I said, this video will be posted for you to rewatch. Whatever you haven't gotten, you can rewatch, and feel free to inbox me, the same WhatsApp group that I'm using, or my inbox. Okay, you can just text me in my inbox. Okay, I'll be glad
Okay,
to
sir.
reply to you. Okay. So
Okay,
to
sir.
make you understand, we want to find angle theta, Mr. Emmanuel. I hope you can get me. We want to find angle
Yes,
theta.
I can.
Then we said from counterclockwise, moving counterclockwise from the positive x direction. The positive x direction is that. Then moving counterclockwise, we said it's 250. That is the angle right arising from that point to that point. So now what we are interested in is the angle theta. So we know that this straight line is 180 degrees. So we can subtract 250, 180 from 250 and get the desired angle, which is 70. Okay. Then it's simple
Yes, sir.
basic of mathematics. We know that the x component is r cos theta and the y component is equal to r sin theta. Okay, so the x component will be given by my r is 7.3, isn't it? So someone to punch what is 7.3 and someone else to also punch that number 7.3 sin 70. What are you getting? And make sure that hello, what is the answer, guys?
2.496.
2.496. Then someone
96,
else,
yes.
to punch this angle. Someone who is saying denke, they were able to hear what you are saying, sir. Please mute your mic. Hello, let's mute our mics.
6.859.
6.859.
859.
So 6.86 like that. So now when you are answering your question, so question A wants us to find the x component. Question B wants us to find the y component. So the x component is equal to, so instead we said the angle is positive 2, isn't it? But it's in the third quadrant, and the third quadrant is given by a negative sign. So it's negative 2.496. Then the y component is also in the third quadrant, which is a negative answer, negative 286. These are my components, okay? In meters. Units are very important in physics. Meters. Any question, guys?
Sir,
Yes.
concerning the significance of the y component and the x component, are they not supposed to have the same number of significant figures?
Yeah, that's correct. But looking at this number, if I convert it like to these significant figures, it will give me like negative 2.50, isn't it?
5.
Yeah,
Yes, sir.
50 meters. Yeah. So we can leave it there, but even this one, they will still mark you. Okay. Someone else. Any question? Ines. So I want you to try out this question on your own. Then you inbox me the solution. Okay. You've seen the question.